This episode is brought to you by HASA. Liquid is clearly better. Liquid chlorine is the highest purity, works immediately, has no added cyanuric acid or calcium, and it will leave your pool safe, clean, and clear. And by the Bottom Feeder professional grade battery powered vacuum system. It sucks to clean pools, so cleaning pools sucks less. Get $100 off with code DVB100.
This episode is brought to you by Skimmer, the #1 pool service software in North America. With Skimmer, you can streamline your schedule, grow your revenue, and keep your customers coming back with 5-star service. Whether you're a one-person operation or an established team, Skimmer is your partner in success. Visit getskimmer.com/poolguy to try Skimmer for free for 30 days.
The Pool Guy Podcast Show. The Pool Guy Podcast Show. The Pool Guy Podcast Show.
Hi, welcome to the Pool Guy Podcast Show. In this episode, I'm going to go back to the basics. This is kind of a new series. I'll probably do several podcasts in this series, back to the basics. And I'm going to go back to basic water testing, what to test for, how often to test for it, and what you're looking for to make dosage adjustments. Are you a pool service pro looking to take your business to the next level? Join the Pool Guy coaching program. Get expert advice, business tips, exclusive content, and get direct support. From me, I'm a 35-year veteran in the industry. Whether you're starting out or scaling up, I've got the tools to help you succeed. Learn more at swimmingpoollearning.com. The question that hardly is ever asked because it's one of those assumptions, but I think it's worth addressing, is why are we trying to balance the pool water? It's kind of basic to think about it. But if you look at a backyard pool, you notice that you would want to keep it in a blue state. And of course, the water color depends on the color of the plaster. But I'll just say you want to keep the water clear and swim ready. And why is that? Well, the natural state of water is a swamp. So if you have been doing pool service for long enough, you've run into these green pools where there's actually tadpoles growing in it. And there's frogs, and so this is like the natural state of water when it's not flowing, when it's not being treated by chemicals. And so you want to prevent that, of course, because no one really wants a swamp in the backyard. It would cause all kinds of problems. You'd have mosquitoes, you'd have, of course, you'd have frogs. There was one pool in Florida, I remember one of my group members posted a picture of it, there was fish in there. We were all wondering, why is there fish in there? Well, the customer put some fish in there because he wanted the fish to eat the tadpoles and the mosquito larvae. And so that is like an extreme example of a swamp pool and the natural state of water plus fish. And I think it's one of those things where we're balancing the pool to maintain that water in a crystal clear blue condition. And there's other factors involved. Now, I don't want to go too deep into the LSI, the Langelier Saturation Index. And this is one index that's used to help balance the water and basically determine if the water in the pool is corrosive, which can destroy pool equipment, cause staining in the plaster, or scale forming, which can cause scale and your pool starts to feel like sandpaper. If you wanted an easy way to calculate the LSI, of course, go to the Orenda app, go to their website. If you go to my website, swimmingpoollearning.com, on the homepage, there's the Orenda. There's a quick link to the Orenda LSI app, and just to the left of it is the poolcalculator.com. And I'll touch on the poolcalculator.com when I talk about dosage in a little bit. But basically, you would want to have these apps available for the LSI to see if your pool is scale forming or corrosive, or the water in the pool, I should say, not the pool itself, and how to dose the pool once you get your test factors and the readings from that. So what should you be testing for? Well, obviously, you should be testing these 3 things on a regular basis: the pool's chlorine level, the pH in the pool, and the alkalinity. Now, some secondary tests that don't need to be done quite as often, I would say you would want to do these monthly or quarterly depending on your area, but you definitely would want to test for your calcium hardness, and you want to test also for cyanuric acid. And there's other tests depending on your pool type. If you have a saltwater pool, you want to test for the salinity or the salt level. total dissolved solids is another whole layer of testing. Probably won't go into that here, but there is some more factors in the water. Basically, TDS, or total dissolved solids, is all the stuff left behind when the pure water evaporates. But this is not something that I think a basic podcast should cover, so I'm going to just go back to the the 4 basic elements. And these are all elements in the LSI also, as well as water temperature, which is actually, chlorine is not technically one of those, but it's one of the basic test factors that we should do. So your chlorine, and you should be doing a total chlorine reading, which is your free chlorine and your combined chlorine, and then you're going to get a total chlorine reading. And of course, you want the combined chlorine to be as low as possible in the pool so that the chlorine is much more effective. That's something that I'll probably do a separate podcast on in itself. But needless to say, testing for chlorine on a weekly basis in the pool, which is a sanitizer. I'll back up a little bit. The chlorine is used to keep the pool swim ready and safe, so it sanitizes the water. So part of keeping this body of water in this unnatural state, which is against the natural state of water, which is crystal clear and virus and bacteria free, is to have a sanitizer. And chlorine is a primary sanitizer used in the industry. You have your tablets, your trichlor tablets, your calhypo, your liquid chlorine, your dichlor. These are all types of chlorines that are added to the pool to keep the water safe to swim in. If you have a saltwater generator, it's actually generating chlorine at the pool side or at the equipment and injecting it into the pool. So these are all things that are necessary to keep the pool blue. And so you're testing for that to see if you have the correct chlorine level. You're also testing for pH, and you're testing for alkalinity, and probably once a month you want to test the pool's calcium hardness. Calcium hardness doesn't move quite as much as the pH and alkalinity in the pool, so testing it every week is not necessary. And testing, of course, the chlorine level to make sure you have the right amount of chlorine in the pool is essential. And I'll touch on that when I go over dosing. But basically, there are some parameters for these tests, and I'm going to use Bob Lowry's target ranges because I think the target ranges are pretty good for beginners, and they're a lot easier than kind of the charts where you have like the range of 7.2 to 7.6. So Bob Lowry's target ranges I think are really good for beginners, and I'll run through those right now. So when you're testing the pool water, this is what you should be going for with these ranges. So your free chlorine should be 5 to 10 parts per million with cyanuric acid present. Most of the outdoor pools have cyanuric acid in them, and this helps protect the chlorine from being burned and used up quickly by the sun's UV rays. So 5 to 10 parts per million. Your pH, the target is 7.5. Total alkalinity should be between 80 and 90 if you're using liquid chlorine, and then if you're using trichlor, 90 to 100 parts per million. Calcium hardness, 3 to 400 for a plaster pool, and 250 to 350 for a fiberglass vinyl pool. Your cyanuric acid should be 50 parts per million for an outdoor pool. The salt level, of course, should be 3,000 to 3,500. I wouldn't go anything over that. It becomes corrosive. And then, of course, your LSI with all of that should be negative 0.3 to 0.0. Slightly negative is perfect balance. And basically, you want to adjust your free chlorine level based on the cyanuric acid level. I've done a lot of podcasts on this, and the math is pretty simple to do yourself. I'll just give you a few examples so that you can calculate it. But cyanuric acid really affects the effectiveness of chlorine. The more cyanuric acid that's in the water, the less effective the chlorine is in the water. Now, the chlorine is still effective and working, but it's working at a slower rate, and it's not quite as effective at a lower cyanuric acid level. There's kind of a sweet spot because too little cyanuric acid means that the chlorine's burning out of the pool rapidly, which means you have to add a lot of chlorine to the pool, which you don't want to be doing because it's expensive. So you want to get that sweet spot where you're adding enough chlorine and there's enough cyanuric acid to keep it in the pool for a few days before you have to add another dose of chlorine to the pool. So his formula is very simple. If your cyanuric acid level, say, is 80 parts per million, your free chlorine level should be 7.5% of that. So 80 times 7.5%, that is 6. So your free chlorine level should be 6 parts per million. If your cyanuric acid level is at 50 parts per million, and you do this math at 7.5%, your free chlorine level should be at 4 parts per million. So the standard of 3 parts per million that you see in a lot of charts is not really accurate because it's not taking cyanuric acid into the equation and factoring that in. If your cyanuric acid is 150 parts per million, which is very common if you're using trichlor tablets and you haven't drained or partially drained the pool, or if you don't have a lot of rain in your area, this means you have to keep a free chlorine level of 11 parts per million. That's above 10 parts per million you see there, and that's why the cyanuric acid level is important and you shouldn't let it get too far out of range. Now, as far as pH, you really don't want it to get too low in the pool because then it could be corrosive. 7.5 is pretty ideal in my opinion. I think most of the charts will show you 7.2 to 7.4. That's fine. I mean, if you want to keep it that low, it's not going to have a major effect. I just worry about it drifting too low and causing some corrosion in the pool. So 7.5 is a pretty sweet spot. The reason why you want to keep the alkalinity below 100 is because alkalinity and pH are tied together. The higher the alkalinity, the more muriatic acid you have to add to the pool to lower the pH, and the less likely the pH will stay low in the pool. So here's basically what you're looking at. If you have alkalinity, let's say at 160, and your pH is 8.2, it's going to take a lot more to lower it because alkalinity is a buffer to the acid in the pool. So if your alkalinity is at 160 and the pH is at 8.2, you have to add more acid and it may bounce back up rapidly because it's being buffered by the alkalinity. If the alkalinity is at 80 and the pH is at 8.2, you have to add less muriatic acid and it's likely to go down more drastically or quicker and be more balanced and stay lower for a longer period of time. So I'm on the poolcalculator.com app. I definitely recommend this for your phone. And if you go on a desktop or laptop, it's actually free to use. So I have a 15,000 gallon pool in my calculation here. The pH is 8.2 and I wanted to lower it to 7.5 with 31.45% muriatic acid. The alkalinity is at 160. This is all the numbers I've inputted, by the way. So it says I need 1 quart and 7 ounces or 39 fluid ounces. So let me lower the alkalinity to 80 here. And then for that same pool where the pH is 8.2 and I want to drop it to 7.5, I'll just need 21 fluid ounces or 2 cups and 5 ounces. That's because, again, the alkalinity is lower. You don't have to add as much muriatic acid to lower it down because it's not buffering the acid as much, if that makes sense. So let's say your alkalinity is at 200, which can happen, and you want to lower the pH to from 8.2 to 7.5. And again, it's going to bounce up quickly. Just keep that in mind that if you do lower the pH to 7.5 and your alkalinity is at 200, don't expect that to stay down at 7.5 for more than maybe a few hours in some cases because the alkalinity is so high. And it's going to cause you to add a lot more acid to drop it down to that level. So you're going to need 48 fluid ounces, which is 1 quart and 2 cups of muriatic acid to lower it down when it's that low. And there's another factor here that I don't want to really get into, and it's something that, of course, you should consider, and this is adjusted alkalinity. If you have really high cyanuric acid and you're using the adjusted alkalinity, then your alkalinity truly isn't at what I'm saying here. It's actually a lot lower, and I'll go over that, and I'll just give you a brief example of that so you can add this to your equation if you would like to. But I'm trying to keep this basic, and you can see that it's kind of getting out of hand here because chemistry is not super basic in a lot of cases. Here's an example of using adjusted alkalinity. And this is, something that you can do. I don't think it's required in basic chemistry, but it's something that you should be aware of, that this is also something that's done in the industry. So for example, let's say that your total alkalinity is 100, your cyanuric acid level is at 30 parts per million. So you take your total alkalinity of 100, and so you multiply your cyanuric acid level by 0.3. So if your total alkalinity is 100, your cyanuric acid is 30, that's going to be 9. So your actual alkalinity is 91 parts per million. Adjusted alkalinity becomes a bigger factor when the cyanuric acid level in the pool gets really high. So let's say, for instance, your cyanuric acid level is 150 parts per million. So your total alkalinity is 100. So 150 times 0.3, and then you basically get 45, and that means that your total alkalinity is actually 55 parts per million. And you can see how that can be really impactful, because now your alkalinity is pretty much way below 80 parts per million. What can happen when the alkalinity gets really low, in my experience, is that I think this happens mainly when the plaster hasn't, maybe when it's like 1 or 2 years old or younger. A lot of mottling tends to happen in the plaster, which is kind of like a discoloration where you have different color variations in the plaster forming. And it also causes the pH to move rapidly in a downward direction when you add muriatic acid. So you want to be careful with the alkalinity too low in the pool. Fortunately, if you have a cyanuric acid level of 150, it's probably because you're using trichlor tablets, and it's another buffer of pH itself, because the trichlor tablet has a pH of like 2 or 3, which means that it's adding acids to the pool. So the pH is pretty stable, usually at about 7.6 in most pools with trichlor tablets. Now, if it's a small body of water, that may drop down to even lower. So be very careful at that point. If you're using trichlor tablets in a pool that's less than 10,000 gallons and you're using a lot of trichlor tablets, the pH will drop down to a very corrosive level in the pool. So let me circle back to the basic chemistry of the pool and also let you understand how it plays into the LSI calculator. If you have a pool that's out of balance, that's very out of balance, really high pH, really high calcium hardness, really high alkalinity, then of course that's going to be a scale forming pool. It's a given. Just with that equation, and the water temperature is really warm, you're going to have scale forming in the pool based on those parameters. Here's a good example. So in the Renda app, I put that the water temperature is 80, the pH is 8.2, alkalinity is 140, calcium hardness is 400, cyanuric acid is at 50, and TDS is, I just left it at 400. So the LSI calculator shows that I'm at a 0.90, which is a pretty good scale forming pool at this point. By the way, in the Renda app, it does give you the adjusted alkalinity. It's called carbonate alkalinity. And here in this, the alkalinity is 140 with the cyanuric acid at 50. It's giving me a adjusted alkalinity or carbonate alkalinity of 121. On the other end is a corrosive pool. So here are the numbers I put in the Renda app. The pool temperature is 80. The pH is 7.2, and by the way, that's in range in a lot of charts. The total alkalinity is at 70. The calcium hardness is at 140. The cyanuric acid I put at 100, just to give you an example of a pool with a really high cyanuric acid. And by the way, the carbonate alkalinity is 43.96 or 44, the adjusted alkalinity. And I just left the TDS at 400, and I'm at a negative 0.90, which is a really corrosive pool. But a lot of those numbers are within range. If I raise the calcium hardness up a little bit in this pool to something more standard, like 210 or 220, it's still at a negative 0.71. But if you can adjust some of these numbers, I'm going to bring the pH up higher in this pool because the calcium hardness is so low and the water temperature is warm. And I want to bring the alkalinity up just slightly as well, because the alkalinity is a little bit low for this pool on the LSI chart. I'm going to bring the alkalinity up to 100. So here's that same pool with these numbers kind of adjusted differently, and the water is more balanced. Water temperature is at 80, pH is at 7.8 now. The total alkalinity is at 100. The calcium hardness is at 220. Cyanuric acid is still at 100. And now you're actually green. You're at 0.04, which means that it's not corrosive or scale forming. This is why the LSI is kind of important in balancing, because you may think that you're balancing your water by having your pH at 7.4. And if I put the pH at 7.4 in this exact calculation, I'm getting a negative 0.32, which is corrosive. But if you're looking at these charts online and it says 7.4 is ideal, then you have these other parameters, your water is not ideal at that point. So it is important to incorporate the LSI calculator into your equations. when you're ready for it, again, you can kind of get a basic idea. I wouldn't call it a rule of thumb, but if all your numbers are elevated, calcium hardness is high, pH is really high, alkalinity is really high, cyanuric acid may be high in the pool, then you're going to have a scale-forming pool. If all your numbers are low, pH is at 7.2 or 7.4, alkalinity is at 80 or 60, and then your calcium hardness is low in the pool at around 200, then of course, and the water temperature is a big factor, by the way. The warmer the water, the more these factors come into play. The cooler the water, the less these factors come into play in a large extent. So also know the water temperature of the pool. And so you can see that you may think you have a balanced pool when it's not balanced based on this. And that's why sometimes you're wondering, why is my pool having all this scale buildup on the side? Why does it feel so rough? It's because your pool is out of balance with the LSI index. You may have a perfectly balanced pool based on the charts you see online, but the water in reality is not perfectly balanced. And I think I did say I wasn't going to get into LSI too much, but it's hard to avoid when you're talking about balancing a pool properly. And it's really hard to avoid the adjusted alkalinity as well, but it's great that the Arenda app gives you that there. So if you haven't downloaded the Arenda app yet on your phone, go to my website, swimmingprolearning.com, download that app right away, put it on your phone, and at the same time, download the pool calculator, the poolcalculator.com app as well, because that'll give you the dosage based on the numbers you input. And it's really important. I showed you an example of the pH being, of the alkalinity being really high and you wanting to lower the pH down, and how you add different amount of acid based on the alkalinity. So it's important to calculate the dosage properly. I don't think I touched on chlorine dosing, but I'll save that for a separate podcast on Back to the Basic. If you're looking for other podcasts that I have here, you can find those on my website, swimmingprolearning.com. Go there and on the podcast icon, click on that. There'll be a drop-down menu of other podcasts I have recorded. And if you're interested in the coaching program that I offer, you can learn more at poolguycoaching.com. Thanks for listening to this podcast. Have a great rest of your week, and God bless. This episode is brought to you by HASA, providing products that deliver clean, healthy water for every aspect of everyday life. The bottom feeder battery-powered vacuum system, portable, powerful, and only weighs 12 pounds. And Skimmer. Get Skimmer, America's #1 pool service software. Podcast listeners can try Skimmer for free at getskimmer.com/poolguy.